Now, in the Workbench environment, you either can access the Ansys Meshing software by using the Fluid Flow block, or you can access it through the Ansys Meshing standalone system, which will be shown to you in the next slide. To access the standalone meshing system, you have to expand the component system as you can see in this slide, and then click on Mesh, and then drag it over a blank space inside the Workbench environment. Now, when you drag the mesh system inside the Workbench environment, you will see that a system containing the geometry and mesh will appear. Now, before clicking on geometry to draw the related geometry and then continuing to the mesh section, we can simply select the units that we want to draw our geometry in using the unit in the Workbench environment. Now, when you click on the unit toolbar, you will see different unit system will appear from SI, metric, US, customary, and so on. After defining and selecting the desired unit, we right-click on geometry to select the desired drawing software. The built-in software for drawing geometries inside the Ansys include Design Modeler and SpaceClaim. You also can import an external geometry using the Import Geometry option, in which you can add or import geometries from softwares like SolidWorks, CATIA, and Inventor. Now, this tutorial is devoted to teaching Ansys Meshing software only. You can find tutorials related to teaching Ansys Design Modeler software in the MRCFD website. As was mentioned, we simply use the Design Modeler software to create our needed geometry for the Ansys Meshing software. Therefore, we simply click on Create and then go over Primitives and select Box. Now we create the selected box without changing any settings. After creating the selected box, we simply exit and close the Ansys Design Modeler software, and then we double click on the Mesh button so that Ansys Meshing software will be opened. Now, in the Ansys Meshing software, you will see different ribbons from Home, Mesh, Display to Automation. All of the shown ribbons will grant you different accessibilities. For example, if you click on the Home ribbon, you can have access to basic commands like generate, section plane, which will be explained in next slide. Also, you can again change the units by clicking on the units. If you click on the Mesh ribbon, you can see different settings related to mesh generation. If you click on the Display ribbon, you can see display settings related to showing the object, as you can see in the graphics window of the Ansys Meshing. For example, if I click on the Show command, you can visualize different options and toolbars. Just like the previous toolbars and ribbons, if you click on Selection and Automation toolbars, you will see different settings. Also, if you click on the options, as you saw in the previous slide, a new window will appear showing you detailed settings related to the Ansys Meshing software itself, which will be explained in next sessions. Also, you can access the help documentation of the Ansys Meshing software by simply clicking on Help button. Also, there are some basic options and commands that you can use to change the viewpoint from which you are seeing your geometry. For example, if I click on the Rotate command, I can easily change the view and rotate the body. Next option would be Pan, meaning that you can simply click on it and then click on your object to change its location in the graphics window. Next four options are related to zooming in and zooming out so that you can see and watch the details of your geometry easier. For example, the third command is the zoom to fit option. If you click on it, you will see the software will automatically zoom out so that the extents of your geometry will completely be placed and fitted inside the graphics window. Zoom to selection command is basically the second command which you select a specific section to zoom in. Next, in front of the select option, you can see the command that I'm showing right now. And if I click on it, you can select between single selection and box selection, which basically means that you can select different entities by selecting box selection at once. And if you select a single selection, you can only select one entity at a time. Now the next four commands, as you can see here, are shown with green color. Now if I click on the first command, you can simply select only vertices by the mouse click. For example, while selecting this command, you won't be able to select any edges or faces or the volume of your geometry. You only can select vertices. However, to select the edges of your geometry, you can simply click on the edge selecting command, and then you will easily be able to select the edges. Also, if you wish to select the faces of your geometry, you have to click on face selecting command. And finally, if you wish to select the volume of your geometry, you have to click on the volume selecting command. Also, on the lower right section of the graphics window of the Ansys Meshing software, you will see a coordinate with 3 axes of X, Y, and Z. If you click on each of these axes, you can change the viewpoint of your geometry in that direction. Also, if you click on the blue sphere shown in the middle section of the compass, you will be easily able to view your geometry in an isometric view. On the outline section, you can see different entities from geometry, materials, coordinate system, and the mesh itself. Now, if you pay attention to the mesh, you will see that a Thunderbolt icon has appeared next to it, meaning that this item needs to be generated. Therefore, we click on the generate button so that the mesh is created over our geometry. Now, as you can probably remember, we talked about 3 commands that would be enabled when we create the mesh over our geometry, which are the node selection command, surface selection command, and element selection command. For example, if you click on the node selection command, you will be only able to select the nodes between each element. However, if you click on the element surface command, you can select the surface of each element. And finally, as you probably guessed, if you click on the element selection command, you can select each element separately. Also, if you click on each of the entities shown under the outline section, its details will appear underneath it. For example, if you click on the geometry underneath it, under the details of geometry under definition, in front of the source, you can see the file's location. Or under the type, you can see with what software this geometry has been drawn. Or as for the length unit, you can see we have selected the meters unit inside the Designbuilder software as the unit we are drawing our geometry with. Also, if you expand the bounding box, you can see the extent of your geometry in 3 directions of X, Y, and Z. Or for example, if you expand the properties, you can see the volume of your geometry. Also, if you click on the subsection of the geometry, which is the solid part, you can see the details will change. For example, under the details of solid, under the material section, you can change the fluid or solidness of your geometry, just as you could in the Designbuilder software. There are also some similar details shown here. For example, if you expand the bounding box, the same settings will appear as the geometry setting. Just as was explained, if you click on the mesh entity, you can see the details section will change. Now the details shown here are the global settings that would be applied over the geometry for mesh generation. You can also add or define some customized commands or local commands by simply right-clicking on mesh, going over insert, and then selecting different commands shown here, which you can use to create customized mesh over your geometry. As for the local commands shown here, they will be explained in the upcoming slides. Now, after clicking on the mesh entity, the details of the mesh section will change. These details include display, default, sizing, quality, and so on, each of which will be explained step by step. For example, under the display section, if you click in front of the display style, you can select how the elements of your geometry are shown. For example, if you change it from use geometry setting to element quality, you can see the element quality for each of the elements of your geometry. Now, because all of the generated elements for this geometry are in the cubic form, they all have element quality equal to 1. Or for example, if you change it to aspect ratio, you will see the value of the aspect ratio for each element is equal to 1. But if you change the display style to skewness, you can see a range of colors are assigned to your elements. However, if you pay attention to the values shown here, you can see the representing values for each color has a very small value which is almost equal to 0. However, there are some bugs in this software which prevents the correct color range to be shown. The ANSYS Meshing software is a very intelligent software that is capable of creating mesh over your geometry for different physics. For example, in front of the physics preference, right now you can see that the ANSYS Meshing software has created mesh for its geometry for the physics in which mechanical analysis are to be done. However, if you click on it, you can change the related physics. As you click on it, you can see different physics are shown here, from mechanical, nonlinear mechanical, electromagnetic, CFD, explicit, and hydrodynamics. By clicking on each of these shown physics, the settings for generating mesh will change and will differ. Now, because the ANSYS Meshing software is generally used for creating mesh for CFD-related physics, use the CFD and continue with instructing the details related to this physics. As you change the physics preference to CFD, you can see some new settings will appear. For example, you can see underneath it the solver preference is selected as default to be fluent. However, you can change it to other softwares like CFX or Polyflow. As for the element order, if you click on it, you can see there are 3 options from program controlled, linear, and quadratic. For the program controlled, as its name says, it selects between linear and quadratic based on the physics you have selected before. Now, if you wish to know the difference between linear and quadratic element order, watch the next slides. Now, to understand the difference between linear and quadratic element order, we first select linear and then click on Generate Mesh. After the mesh was generated, we click on the node selecting command and then click on the vertices of each element. If you pay attention, you can only click and select the vertices of element, and no other node can be selected between these 2 vertices. However, if you change the element order to quadratic and then click on Generate Mesh, then you will be able to select nodes between each vertices for each element. You may also pay attention to the nodes under the statistics section shown here. When we select the linear element order for our geometry, you can see the number of nodes is equal to 2197. But when we change it to quadratic, you can see this value changes. Now, changing the element order from linear to quadratic has the pros of increasing the precision of our calculation. But this pros comes with the cons of increasing the computational cost for our calculation. Now, the next option is the element size, which by its name you can understand that it defines the size of each element. By default, its value is set equal to 8.66 centimeters. You can change this value. It should only be pointed out that when you define the element size here, that does not necessarily mean that the size of each element is precisely equal to this value, but this means that the size of each element is less or equal to this value. For example, in order to calculate the difference and length between 2 nodes of an element, we select the element selecting command and then select 2 elements that are placed next to each other. then you will see that the length between these two is less than the default value set in here. For example, if you select the two nodes shown here, you can see the distance between them is equal to 8.33 centimeters, while the default value for the element size is equal to 8.66 centimeters. Now let's change the element size and see how it affects the distance or length between two consecutive nodes. For example, you can see here that we have changed the element size to 4 centimeters. Now if we do the same and select the node selecting command and select two consecutive nodes on our geometry, you will see that the distance between them is exactly equal to 4 centimeters, meaning that the element size can be less or equal to the element size value that we define under the default section. Along with the element size option, you can see there are other settings under the sizing section as well. Now the settings under the sizing section will be in second priority in comparison with the element size, meaning that when you define an element size other than the default value, the settings defined in the sizing section won't have any effect. Therefore, to turn back the element size to its default value, we change its value from 4 centimeters to 0. By defining and entering the value of 0 for any settings in Ansys Machine software, the default value will be selected.